Good morning, everyone. So today we'll just finish module 6, and then I'll start with module 7. But I just like to remind to you that we're not going to have this synchronous lecture all the time. Okay, so this is the last time that we have this synchronous one. So the next time we meet is mostly you're going to ask question with regards to the material in our course pack. So looking at the module 6B, where we have the acid-base equilibria, so if you're going to look at the learning outcomes that we have there, okay, I think we covered almost everything, okay? So we have there the natures of acids and bases, water and pH, the strength of the acid, that's the strong acid, strong base, weak acid, weak base, and then we talk about buffers, during that time. So I want you to go over the learning activity that can be found in your course pack. Okay, so there's some practice tests that you can look over there. So there's says here answer quiz number 2 that you have there. And then when we go to the module 6C, we started with the solubility, okay, the concept of solubility. And then today we're going to go on metal complex equilibria. So we solved some problem in the solubility, and today we're going to discuss the effects of the common ion, complex ion, and weak acid formation on the solubility equilibria. Okay, and I want you to go over some of the examples that you can find there in your what we call course pack. Okay, and if it's still not clear to you, that's what we're going to do next meeting. And then we will start with what we call module 7, which is just redox and electrochemistry. So today I'm going to cover redox reaction and balancing redox reaction. Okay, so that will be the coverage that we have today. So ito na yung last na parang synchronous lecture. And then after that, it's mostly you who are going to ask question. And if you're not going to ask question, I will start it with some of the questions that we have in the course pack. So sinabihan ako, wag na akong lumayo doon sa materials na meron sa module, sa Moodle ninyo. Okay? So, the link for this recording will be posted together with the one that we did last Tuesday. So, teka lang. Okay. So, isasama ko lang yan doon sa dalawang unang link. So, dadagdagan ko lang doon sa Google Meet natin. Okay? So, last time, we have already started on what we call solubility. So, what we're going to solve today is what are the factors that can affect solubility. Okay, so for instance, if we have this calcium sulfate, so it's dissociate to give you calcium 2 plus and SO4 2 minus. Now, what if we have a common ion? So when we say a common ion, one of the ion here has another source aside from CaSO4. So how does it affect the equilibrium? So let's say in addition to calcium sulfate, you have what? Calcium hydroxide. That can be the source of your calcium. Or you can have sodium hydroxide, sodium sulfate, which can be the source of your sulfate ion. So what happened if either one of them are present coming from other source? Which reaction will be favored, the backward or the forward reaction? Anyone?
Backward.
The backward. So if the presence of the common ion favor the backward reaction, how does it affect the solubility of, let's say, calcium sulfate? Will it increase, decrease, or remains the same in the presence of a common ion? Anyone?
Decrease po ba?
Okay. So since the backward reaction is favored, so that means the calcium sulfate solubility will decrease. So that's one factor that affects the solubility, the presence of the common ion. Now another one would be the effect of the pH. So this is true if you have hydroxide. So for instance, you have this. So how does high pH and low pH affects the solubility of magnesium hydroxide? So maybe we go with the high pH here. So what is the effect of high pH in terms of the concentration of H plus and the concentration of hydroxide? Anyone? So ano mangyayari pag high pH? Ano yung concentration ng H plus? Ano yung concentration ng hydroxide? Tataas ba, bababa, or pareho lang?
Yung H plus po tataas.
Tataas ba?
Bababa po yung OH.
Anyone who wants to disagree with his answer? Ano yung relationship ng pH sa H plus? Last meeting? Di ba parang siso? Isn't it the higher the pH, the lower the H plus, the higher the hydroxide, the lower the pH, or the higher the pH, the lower the H plus, and the higher the OH minus, the lower the pH, the higher the H plus, and the lower the hydroxide. So how does it affect the solubility of magnesium hydroxide? Anyone? So high pH, ano mangyayari sa hydroxide dito? Will it go up, go down, or the same?
Bababa po.
Bababa, high pH. Look at this. Remember the relationship of H plus with OH minus? Saan mataas yung OH kaysa sa H plus? Basic, right? And when we have a basic condition, when you have a high pH. So what happened to the concentration of your hydroxide at high pH?
Tataas po.
So this will go up. So how it will affect the solubility of magnesium hydroxide? Which is favored? Backward, forward reaction, or nothing? It's just the same.
Sir, bababa po yung value nung sa sodium. Ay, dito po sa MgOH.
So the one that is favored, since this is what increases based on the Chatterley's principle, is the backward reaction, resulting in lower solubility of your magnesium hydroxide. Now, if the pH decreases, what happened to your hydroxide here? It will go down. Okay? So once this goes down, which one is favored?
Forward.
The forward reaction, hence increasing the solubility of magnesium hydroxide. So what does it mean? If you have magnesium hydroxide, if you want its solubility to increase, put it in acidic solution. Because what happened is the hydroxide that it has will react with the H plus in acidic solution, favoring the forward reaction, hence increasing its solubility. Claro ba? Is that clear? So this is the effect of what we call the pH. Okay. Now, if you want to look at the numerical aspects of this one, we have a problem solving question here. So what we know in the common ion, it decreases the solubility of the salt. Now let's look at it in terms of numbers. Okay. The best proof of a concept is by getting evidence in terms of numbers. So we are asked to calculate the solubility of silver chloride in grams per liter in a 6.5 times 10 to the negative 3 molar silver nitrate. Compare it with the solubility of silver chloride in just water. So we can put the KSP here and the molar mass of your silver chloride. Okay, so if we're going to look at the molar mass of silver chloride, we have what? I think it's 143.32. 143.32 grams per mole. Now, in terms of KSP, I think it's here. Silver chloride, 1.6 times 10 to the negative 10. So let's try to look at the reaction. Silver chloride. Solid dissociating to give you silver ion. So you could say you don't have anything at the beginning and then you form what? We can use S instead of X. So in the end, you have S and S. And you can put the KSP as equals to silver ion times chloride. And then you can replace it with the value of the KSP, 1.6 times 10 to the negative 10 equals to S times S. So S is just the square root of this, which is equals to what? Anyone?
1.26 po, sir, times 10 raised to 5.
Right. And if we want to get it in terms of grams per mole, because this is molarity, all you need to do is what? The 1.26 exponent negative 5 times 143.32, which is around 1.3. Point 0019 or 18. Ano yung nakukuha nyo? That's a negative 5. Okay, just to make sure. That's what you get? So this is the solubility of your silver chloride in just water. Now, what if we have this one? What will change? So where will I put the 6.5 times 10 to the negative 3? I'll put it here. I don't have that one, and then I have a plus S, and I have a plus S, so I will end up with 6.5 times 10 to the negative 3 plus S, and then I have S here. So if I put the KSP there, I will have what? 1.6 times 10 to the 10 equals to 6.5 times 10 to the negative 3 plus S times S. And you can make an approximation here wherein this value S is so small that if you add it with the 6.5 times 10 to the negative 3, it's still 6.5 times 10 to the negative 3. And you can check it later on when you get the value of S. So if you have that, what will happen? So you just divide both sides by 6.5 times 10 to the negative 3. So the value that you will have here will be equals to what?
2.5 times 10 raised to negative 8.
2.5 times 10 to the negative
8.
which you're going to multiply with the molar mass will give you what? Is this what you get? Please check. I might be wrong. Tama ba? So, see the evidence? When it's just water, this is the amount of silver chloride that dissolved. But if you have a silver nitrate there, the solubility just went down. So that's what it means. The presence of the common ions decreases the solubility of the salt. Okay? Question before we go with the metal ion complex. So in the metal complex equilibria, so usually we have the formation of what we call the complex ion. So this is just an ion containing a central metal cation bonded to one or more molecules or ions. So you have your cobalt reacting with chloride to give you cobalt chloride. Now, if you have a complex ion, you expect it to be a charged material. Now, my question, when you have a charged material, what does it mean? Is it solid or part of the solution? If you have a complex ion, will it be a solid particle or it will be part of the liquid component? So So most likely it is part of a liquid component. Now, if you're going to use the law of mass action here, wherein you have the products of the products over the products of the reactants, you will end up getting a new K, known as the formation constant or stability constant. So this is still part of the so-called equilibria. And the higher the Kf, the higher stability. So just showing you an example here, wherein you have a cobalt hydrate and a cobalt uh, chloride. So what's the difference? You add this with HCl. So the Cl will displace the water that you have. And what happened here is you're going to have different color. Now, why do you think you have different color here? That will be answered in the next module. Okay? Now, I want you to look at the value of the Kf here. Compare it with the value of Ka, Kb, Ksp. Are they the same or they're different from those other Ks? So if you're going to look at the value that you have here, there are what? 10 to the positive. If you're going to look at the values of these, they are 10 to the negative. So what does this mean? So this means that if you have the formation of the complex, they're more likely to go to completion because of the high Kf value. Because there are more products compared to the reactant. Compared to this one, that means that they're only going to happen to a certain extent because their K value is low. So that's the main difference of this K compared to the other. Okay? So question, before we go with the what we call redox reaction. Ano? So we're going to talk about redox, or the one that we call the reduction reaction equation, or redox reaction. But before we go on that, we need to learn first this concept of quantum number, or in your course pack, you can call it the quantum, the oxidation state, not quantum number. Oxidation number, oxidation states. So what are these? Why do you need to know this one? Okay, you need to know this one because this is the only way for you to determine if a given reaction is a redox reaction that we're going to discuss later. So before we go with the redox reaction, ask ourselves, okay, why do we need to assign this so-called oxidation number? What is its usefulness? Okay? So when we're talking about oxidation number, this is just the charge of an atom would have in a molecule or an ionic compound if electrons were completely transferred. How do we determine the oxidation number of a given element? Then there is a set of rules that we need to follow. Okay? Number one, if you have free elements, the oxidation number of that element is 0. What are these free elements? Whatever they are in pre-states or in pre-oxidation state, like sodium metal, beryllium metal, potassium metal, lead metal. So this is different when they are charged ions. So when we say pre-elements, this is what they are as it is. The hydrogen and the oxygen gas, the phosphorus, all of them will have an oxidation number that's equals to 0. Okay? Second rule, in monatomic ions, the oxidation number is equal to the charge of the ion. So if you have an ion that has a charge +1, +2, -1, -2, whatever the charge that you have there, that's the oxidation number. So if you have K plus, so that means it's +1. Okay? Next, so the example that we have there, if you have an Li plus, your Li is +1, Fe3 plus, it's +3, oxygen 2 minus, then oxidation number is 2 minus. Next, whenever you have an oxygen, especially if it's part of a compound, its oxidation number is usually -2. The only time it's not -2 is if you have a peroxide. Because if you have a peroxide, its oxidation number is -1. Now, there are what we call some set of rules that's the first thing that you need to assign because the other has more than one oxidation states. And that's the answer to your question, why the cobalt hydrate has blue while the cobalt chloride is red. In fact, we will go on that later on, don't worry. Now, if wherever we have a hydrogen, it's always +1 except when it is bonded to a metal in binary compounds, which in this case its oxidation number is -1. If we have the group 1A metals, the group 2A metals, if they are in charge form, then we can assign the oxidation number as +1 for group 1A, +2 for group 2A, and for group 7A, like fluorine, okay? So fluorine is a 7A. So why do you think it end up with a -1? All group 7A. Anyone? Bakit yung nasa group 7A, they end up usually with a -1? Anyone wants to answer that?
Sir, may relation po ba yun sa valence electrons?
Yep. 7 minus 8 will give you what?
Negative.
And why is that in group 6A end up with -2, like oxygen? Because 6 minus 8 is equals to -2. Okay? But the most important rule that you need to follow is this one. The sum of the oxidation number of all atoms in a molecule or ion is equal to the charge on the molecule or ion. For instance, water. What is the charge of water? Anyone? Iinom lang ako ng water. Kaso wala naman ang aking tasa. What's the charge of water?
Minus 1 minus.
It's zero.
I see.
You don't put any charge, that means it's zero. How did you end up with zero? Well, you look at the oxidation number of the elements in water. Hydrogen is what?
0 po.
Hydrogen is water here. This one is not the same as this. Klaro ba tayo doon? Ano oxidation number ng H2? Anong oxidation number ng H sa H2? 0. Ano ang oxidation number ng hydrogen sa H2O? And who? Nandyan who? It's positive 1. So positive 1 times 2 will give you what? Positive 2. Now, what is the oxidation number of oxygen in water?
2 minus.
2 minus. And you only have 1, so positive 2 plus negative 2 will give you what?
0.
Which is the charge of your molecule. Let's try this one. Assign the oxidation number of the elements in bicarbonate. So, how are you going to start? You start with what you know. So I can start with hydrogen and oxygen. So what is the oxidation number of hydrogen here? Anyone?
Positive 1.
Positive 1. How about the oxygen here? What's the charge of the oxygen here? Hello?
Negative 1.
It's negative 2. Remember here? Now, what do we do? We're going to use the value that we have there. So I can put here, so this is what? Positive 1 plus the C that I don't know, plus negative 2 times 3 equals to negative 1. This is the charge that you have. So all you need to do is calculate for C. I can rearrange it with the one that we have here, where you end up C is equals to 4. So if I could rearrange this one, so I have what? Positive 1 plus C plus negative 6 equals to negative 1. So I leave C on one side, so positive 1 plus negative 6, that's negative 5. So negative 1 plus 5, giving me plus 4. Analyze, because I want you to have a sure correct answer for this type of question. In an ACS exam, there's always one questions like that. Why do I know? Because I also do questions in the ACS exam. Now let's try another one here, CH4. This is based on the horsepack that you have. What is hydrogen oxidation number and what is carbon oxidation number? So what is hydrogen? What is the oxidation number of hydrogen in methane? Anyone?
Positive 1 pa rin ba, sir?
Positive 1. Between C and hydrogen, you are sure of the hydrogen. Carbon can have more than one. Other elements that's not listed in the numbering here, they can have more than one element. And it is going to be dependent by the other one that's listed here. So if this is a positive one, what's the charge of your carbon here?
Negative.
Negative what?
2?
Hmm? Why negative 4? What's the charge of CH4? I want you to nail questions for here from this problem. What is the overall charge of CH4? Anyone? If it has no charge, what's the charge is?
Positive.
Wala ngang charge, positive.
Wala, 0 pa.
Ginigising niyo ako sa antok ko eh. Pag wala kang nakitang charge, ibig sabihin 0 siya. Okay? Dito nakakita ka ng charge, so that means negative 1. So kapag 0 siya, positive 1 dito, so positive 1 times 4 will give you what? Positive 1 times 4.
Positive 4.
Positive 4. So kailangan mo ng number nung C na pag inad mo sa 4 ay magiging 0. Ano yung number na yun?
Negative 4.
Klaro? So isa pa, ito. MnO4 2 minus. So ano yung pwede nyong i-assign agad based dito sa rules na meron tayo sa oxidation number?
Oxygen po.
Oxygen. Wala kang nakitang manganese doon sa 1, 2, 3, 4, 5. So that means oxygen. So this is what? Negative 2. So anong oxidation number ng manganese? Pag inad mo si oxide sa 4 na oxygen, magbibigay sa iyo ng negative 2 na charge.
Positive 6.
Positive 6. We can try positive 6 plus negative 2 times 4 will give you negative 2. So this is what? Positive 6 plus negative 4, which is equals to negative 2. Nagiging clear na ba? At least may isa ka na kayong correct answer sa module 7. Last but not the least, Fe2O3. Fe2O3. So ano yung oxidation number ng mga elements sa compound na ito? Anyone? Saan tayo magsisimula?
Sa oxygen po.
Okay? So ano yun sa oxygen?
Negative 2.
Okay, so that's a negative 2. And that makes iron as what?
Positive.
Positive
3
what?
po. 3.
3. Because if you're going to do that, you have a plus 6 here plus negative 6, which give you 0. So let's go back to those cobalt thing. Remember this one? So let's assign the oxidation number of the cobalt here. So what do you think is the cobalt here compared to the cobalt here? Are they the same oxidation number? What do you think is the charge here? Take a guess.
Positive 4, sir.
Positive 4. Yung iba, ano? Lagyan natin yung mga guess nyo.
Positive 2.
Positive 2. O, ano pa? My answer is positive 2. Why? What's the charge of this water? Anong charge ng water? Anong charge ng water? 0. Di ba? So, kung 0 siya, i-multiply mo sa 6, ano yung sagot? 6 times 0.
0 po.
0.
0. So, ano meron ditong net charge? Plus 2. So, yung net charge na yun, yun yung charge ng cobalt. Gets nyo? Now, tingnan natin to. Anong charge ng chloride? Anyone?
Negative 2.
Negative 1. Nilagay ko na dito. Why did I say negative 1? If you have a periodic table, nandoon siya sa group 7. So, 7 minus 8 will give you negative 1. Now, if that is negative 1, what's the charge of your cobalt? In cobalt chloride? Is it negative 2? Positive 2? Positive 1? Positive 3?
Positive
Ano?
2. Positive.
Positive 2 din. Now, ask yourself, pareho silang positive 2. Bakit magkaiba yung kulay? Ano kaya nagpaiba sa kulay nila?
Nawalan po ng oxygen.
Nawala na oxygen? Nakikita ko na yung sagot sa slide. Ito, oh. Yung isa, 6 yung nakakapit sa kanya. Yung isa, 4 lang. Okay? So that's enough to change the color that they have. But in some instances, in some, like you say, material, the color change like Mn. Iba yung Mn2 plus kaysa doon sa Mn7 plus. I don't know if you're familiar with KMnO4. I think we solved KMnO4 here. So that's a plus 6. But what if our KMnO4 is like this, KMnO4 minus? Ano yung oxidation number ng manganese dito? Is it the same as the one that you have here, the MnO4 2 minus? So this will be
Positive 1.
positive 7. MnO4 minus. So ano yung oxidation number, no, Mn. The charge is -1. Compare it to the one that is MnO4 2 minus. So, -2 talaga in oxygen. But here we say it's 6 based on our previous calculation. But how about if it's an MnO4 minus? Will it still be 6? It will become 7. So usually KMNO4 is, if I'm not mistaken, violet. KMNO4, K2MNO4 is usually, if I'm not mistaken, green. I'm not sure. Now, the question I'd like to ask to you is, why bother to know this oxidation number? Okay? Because the only way for you to determine if you have a redox reaction is by looking at the change in oxidation number or oxidation states. Why? Redox, which is reduction oxidation, is just electron transfer. And for you to determine if there is electron transfer, you have to look at the change in the oxidation number. So when you have electron transfer, one element will lose electron and another element will gain electron. And that's the definition of a redox reaction. So for instance here, magnesium magnesium metal reacting with oxygen to give you magnesium oxide. You did this. You familiar with sparkler? Yung ginagamit ninyo sa New Year? So usually it's made up of magnesium metal and then you heat it, you lit at the fire. So nag-ignite doon and in the end, magpo-form siya ng magnesium oxide. So the question, is this a redox reaction? How are you going to answer that? You apply the oxidation number or oxidation states in each of them. So what's the oxidation number of magnesium? Anyone? Naku, kung ganun kayo, baka... Ano oxidation number ng magnesium metal dito? Nagugutom na yata kayo eh. Ano?
+2 po.
Balikan niyo yung recording ha. Kasi ang sagot is 0. Yung +2 dito. Bakit 0 to? Pakisagot. Anong sabi ko? Magnesium metal. Anong definition yan? First statement, pre-element. Oxygen gas. Ano oxidation number dito?
-1. Tama ba?
Nakikinig ba kayo? Hindi. Kung in person tayo na, pinag-upog ko na yung mga ulo nyo eh. Ayan oh. Ano ibig sabihin yan? Andiyan na example oh. Napapagising ako sa sagot nyo eh. Balikan natin. Balik tayo dito. Ano oxidation number ng magnesium? Metal.
0.
0. Bakit?
Kasi free element.
Kasi
Hindi ba?
free element siya. Okay? Ang oxygen, ano yung oxidation number dito?
0.
0. With the same reason dito. Now, ang tanong, ang magnesium oxide ba ay free element?
Hindi na.
Hindi. It's a compound. So, hindi siya pwede magkaroon ng 0 oxidation number. So, ano yung oxidation number ng magnesium sa magnesium oxide? So, kung hindi nyo kaya sagutin, puntahan nyo yung periodic table. Anong group number siya?
Positive 2 po.
Positive 2. Hindi ako papayag na hindi nyo ito masasagot ng tama. Yung oxygen, ilang beses tayo nag-example ng oxygen sa compound. Ano ang oxidation number niya?
Negative 2 po.
Negative 2. So ngayon makikita ninyo, yung magnesium from 0 naging
Positive 2.
positive 2. Yung oxygen from 0 naging
Negative 2.
negative 2. Now, ang tanong, ano nangyari sa electron dito? Nawala ba siya or nakatanggap siya ng electron?
Nakatanggap po. Or nagkaroon ng
Remember,
charge.
from 0 to positive 2, ano yung charge ng electron?
Nawalan po. Negative kasi.
So, paano ka magkakaroon ng positive? Pag nawalan ka ng negative sign or nakatanggap ka ng negative sign? Kailan ka magiging negative? At kailan ka magiging positive? Kapag nawala ka ng negative. Kailan ka magiging negative? Kapag nakatanggap ka ng negative. Klaro ba yun? Because ang tatandaan ninyo ngayon, itong term. Ano yan? Loose electron, which means it's undergo oxidation, which means it's the reducing agent. And then yung isa, gain electron, which means it's undergo reduction, and it's the oxidizing agent. So ano yung na-oxidize? Anyone? Anong element yung na-oxidize?
Yung oxygen. Siya po yung nag-gain na electron.
Tingnan mo uli yung definition dito. Yung ba nag-gain ng electron, siya nag-oxidize? Alin ang nag-oxidize? Ayan no, loose electron oxidation. So ang nag-oxidize ay magnesium. Alin yung na-reduce or nag-undergo ng reduction?
Oxygen.
Yung oxygen. Okay? So tandaan nyo to. Now, ang tanong ngayon, alin yung oxidizing agent? Alin yung reducing agent? Anong sagot? Pag ang question, in a given reaction, which is the oxidation reagent? Or which is the oxidizing agent? In the given reaction, which is the reducing agent?
Yung reducing po yung magnesium.
Okay?
And
Yung oxidizing agent is
oxygen.
yung buong O2 ang ilalagay ninyo. Tandaan nyo yan. Hindi ako convinced na may natutunan kayo. That's why I'm going to add another one. So let's say we have a reaction. No, maybe I can make it like this. Ito yung mga sasagutin ninyo. Ano yung na-oxidize? Ano yung na-reduce? Ano yung oxidizing agent? Ano yung reducing agent? But before that, assign natin yung oxidation number. So, tell me when you're ready to assign which is which. Ready na? So, saan yung unang gusto mag-assign? Anong element?
Hydrogen gas po. Yung H2.
So, ano to?
0 po.
Okay. Next.
Hydrogen po sa HCl.
Okay.
Positive 1.
Okay, very good.
Tapos yung Cl po, negative 1.
Okay. Next. Itong Cl dito, anong charge nito? Anyone?
Negative 1 po.
Okay. So anong charge ditong sink na to? Ito ba'y, I think I need to put the sink there. So anong charge nun, anong oxidation number ng zinc dito? This is a zinc metal.
0 po.
0 po.
How about the zinc here?
Positive 2.
Okay. So pwede nyo nang sagutin yung mga tanong. Alin yung na-oxidize? Alin yung na-oxidize? So, ang gagawin nyo, tabulate nyo lahat ng element. Tapos, tingnan nyo, ano nangyari sa oxidation number? So, this is +1, -1, 0. Tapos, ito, naging 0. Ito, -1 pa rin. Ito, +2. So, alin ang na-oxidize? Which one undergo oxidation? Ano yung Leora? Ano yung Geroa? So, ang hydrogen, ano nangyari sa hydrogen? Positive 1 naging 0. Did it lose or gain electron?
Gain po.
Nag-gain siya kasi nabawasan yung charge niya. So, ano nangyari kapag nag-gain siya? Did it undergo oxidation or reduction?
Reduction.
Very good. How about zinc? What happened to zinc? Did it lose or gain electron? Did zinc lose or gain electron?
Nabawasan po na electron.
Nabawasan siya. So, siya ay nag-undergo ng oxidation. Now, the question is, which is the oxidizing agent?
Hydrogen
Okay.
gas. H2.
No.
Ay, HCl.
Itong mga to, nasa reactant ng mga yan. Hindi yan pwede magpunta sa product. Remember, wala kang product pag walang reaction. So, ano yung reducing agent mo?
Zinc po.
Zinc. Kaya nyo na. Ito yung madali. Pag tinignan yung recording ng unang class, hindi kami umabot dito. Okay? So the next one that we're going to have will be balancing redox reaction. So in balancing redox reaction, what you're going to do is you're not only making sure that the elements on both sides are the same. You also have to take into consideration that the exchange of electrons are also the same. Okay? So let's say we have a problem like this, the oxidation of Fe2 plus to Fe3 plus by dichromate in acidic solution. So the first thing that you're going to do is write the unbalanced equation. And then what are you going to do once you write it? Anong gagawin natin?
Magbabalance po ng equation.
Magbabalance ba agad? Anong ginawa natin sa previous example? Ano ang first thing na ginawa natin? Anong ginawa natin sa previous example natin?
Tinignan po yung oxidation state.
We assign the oxidation state. So ano yung mga oxidation state dito? Fe2 plus.
Plus 2 po.
Plus
Ay.
2. This one?
Plus 3.
Kung ano yung charge, yun yung oxidation number. If you have only one element on it. So between chromium and oxygen, which one do you know? The oxidation number.
Oxygen.
Oxygen. And that is equals to?
-2.
-2. So from this one, what is CR? Oxidation number.
+6.
positive 6. So the question now is, which one is oxidized and which one is reduced? Hmm? So you have Fe from +2 to +3. And you have chromium from +6 to +3. So alin dyan yung nag-oxidize, alin dyan yung nag-reduce? Because yun yung next na gagawin mo. You have to separate them into two half reaction. One that undergo oxidation half reaction and the other one that undergo reduction half reaction. So alin ang na-oxidize, alin yung na-reduce? Hmm? So ang Fe ang na-oxidize and ang na-reduce ay yung chromium. Why? Here, +2 naging +3. So that means you lose electron. Chromium +6 nabawasan, so that means you gain negative sign. Clear? Klaro ba? And then the next thing that you're going to do is balance all the atoms that are involved other than oxygen and hydrogen. So if you're going to look at this, okay na tayo sa Fe, tig-isa sila, pero dito, dalawa yung chromium, isa lang dito. So that means you have to put 2 there to balance the number of chromium. Now, balance na lahat, pwera yung oxygen and hydrogen. So as you could see, there's a 7 oxygen here. So what are you going to do? So to balance the oxygen atom, you add water. And if you add water, you introduce hydrogen. And to balance the added hydrogen, you're going to add H+. So if you're going to do it this way, ganitong mangyayari. Okay, so may 7 na oxygen doon, so mag-a-add ako ng 7 water. And in doing that, I also introduce 14 hydrogen. So I have to add 14 H+ on the other side. Follow? So, balance na lahat. Okay? In terms of the elements. So the next thing that we're going to do is we balance the charge. So as you could see in the chromium, or in the Fe, one is +2 and the other one is +3. So how are you going to make them equal? You're going to add electron. Now, the question, does this make sense that ang electron ay nasa product side? What happened to Fe2+? Was it oxidized or reduced? Hello? Pwede kayong kumain kung nagugutom kayo. Anyway, hindi ko naman kikita eh.
Nag-reduce po ng electron.
Does this make sense na nandito ito sa product side? Yes, because you lose electron. And if you lose electron, that means it should be on the product side. And if you gain electron, that means it is in the reaction side. May sense ba yun? Because on the other one, you're going to add here 6. Why 6? So if you're going to look at here, this is 2 times plus 3 plus. So you have +6. So you have -2 here, you have +14 here. So that means you have what? +12. So paano mo gagawing yung +12 mo magiging +6? You add 6 electrons. Now, we already balanced the charge in both sides. So the next thing that we need to balance is what? That the number of electrons is the same on both sides. But as you can see, you only have 1 here, you have 6 here. So you need to make sure they're the same. So the only way to make it the same is you multiply it by the number here, and you multiply this one by the number on that side. So 6 times 1 will give you, 1 times 6 will give you 6, and 6 times 1 will give you 6. So, okay ka na dito in terms of the electron. So, kapag inad mo na yung half reaction nila, ito na yung overall reaction mo. So you cancel out the number of electrons because they should be the same. So the next thing that you're going to do, you check 14H, 7 times 2 is 14, 2 chromium, 7 oxygen, 7 oxygen, 6 Fe, 6 Fe. What's the next one that you can do? The charge. So you have here 14H plus, that's plus 14, and then plus negative 2, and then plus 12. And then on this side, you have 6 times 3 is plus 18, 2 times 3 is plus 6. So ano yung nakukuha mo? So 18 plus 6 will give you 24. 12 plus 14, that's give you 26 minus 2, that's also give you 24. So everything is now balanced. And the condition of the question is acidic. This is the one that makes it acidic, the presence of H plus, whether it is in the reactant or the product side. Question. So the next one that we said, what if we have a basic condition? What do we need to do? So if you have a reaction in basic solution, you add hydroxide on both sides of the equation for every H plus that appears in the final equation. So the question, how many hydroxide will I add? Anyone?
Isa po.
Isa lang ba? Remember what the statement said? Add hydroxide to both sides of the equation for every H plus that appears in the final equation. Ilan yung H plus natin?
14 po.
14. So ilan yung hydroxide na i-add natin?
14 din.
So whatever you add here, you also add on this side because you're just trying to balance. So you add here 14. You also add 14 here. Now, if you have 14 hydroxide and 14 H plus, what will happen? You're going to form 14 water. And if you're going to form 14 water, you have 7 water here. This is cancelled out. And you only have here now how many water? Bakit 7? You have 14 water on this side and then 7 on the other side. So if you eliminate the 7, so that means the 14, you have to eliminate also 14. 7 water on that. That's why magiging 7 na lang siya. And then you check again, the numbers of elements on both sides. 7 times 2 will give you what? 14 hydrogen, 14 OH, that's 14 hydrogen. Oxygen 7 here plus 7 there, that's 14, and you have 14 oxygen here. Chromium here is 2, chromium is 2, Fe is 6, Fe is 6. So in terms of elements, you're checked. And then the next one is charge. So you have here what? -2, 6 times negative 2, that's positive 2, that's 12. And then you have here what? You have the 14, negative 14 plus 6 times 3, positive 18. 2 times 3, positive, no, not 8, it should be 6. So if you have here 18 plus 6, that's 24 minus 14, you have positive 10. Negative 2 plus 12 will give you positive 10. Question? Ano? So I want you to look at the course pack by the weekend. And then I want you to go over ahead because we will not have this kind of lecture anymore. You have to have a much more active role in using the materials that were provided to you. And then if you still not understand that, that's the time we can use this synchronous meeting. Because what I heard from some of the other Chem 18 instructor, they told me that they don't usually meet the class synchronously all the time. And if you ask for the materials, the course pack, okay, is a very good starting point. And I think you have some quizzes that you need to what we call do there, some of the so-called self-assessment question. So I would suggest start doing that. Whether it is graded or not, remember the motto that we have, chemistry. So you might as well do any problems that's provided to you because who knows, that's the same question that will come out or similar question will come out in your departmental quiz. So question, before we call it a day or a week. Tanong? Jess Michael, Jemima, John Emmanuel, Aliyah Jade, Aero, Eric Jomin, and Janiel Irvin. May tanong kayo?